rendered themselves. Strip. You stayed in one place. We all went past. We didn't do too much.
I just don't understand why really that my senior year. If we don't know what
They just didn't want to separate like freshmen and sophomore.
I mean, if I don't know how to study right now, I might as well.
Do you?
I know. That's what I'm saying.
Okay. 13 on 5-4. So we're looking for the maximum value on the open interval. So that's looking for a relative max or a local max. So we take the derivative and set the top and bottom equal to 0. There's no bottom, so we just set the top equal. Remember the derivative of cosine's negative, so that's why it's -2. And then I set this equal to 0. And I can divide both sides by -2 to make it a little easier. And then I've just got to solve that. So like where in between negative pi and pi, so on the negative pi is here, pi is also there. So like once around the circle, where is sine equal to 0? That's a terrible circle. That's a good circle, it's just not centered. 0, negative pi, and pi are where we're looking. So sine is 0 here. It's 0 at pi. It's 0 at negative pi. Well, negative pi and pi don't count because it's an open interval. So the only thing I really have, the only critical point I really have is x equals 0. Because negative pi and pi, because that's an open interval, not closed. So I'm just going to work around that. I'll go negative infinity to 0. 0 to infinity. And then I'm going to write down what f prime is doing and then what f is doing. So remember to check, you pick a representative point, and if I'm looking for increasing, decreasing, where do I plug the relative point back into? The derivative or the original? If I'm looking for increasing or decreasing, that's essentially saying I'm looking for slope, isn't it? So I plug into the derivative. If I want a y value, like if you were doing the equation of a tangent line, you plug into the original. The derivative tells you slope or increasing, decreasing. So I'm going to pick like, I don't know, negative pi and plug it in, well, yeah, negative pi is no good. Negative pi over 2, let's say. So don't plug into this because you have like just removed the -2. So it does change the value of it. So what's sine of, let's say we're plugging in negative pi over 2. That'd be -1, right? And then -2 times that would be 2. So the derivative is positive, which means what is the original function doing? Increasing. And then here, let's say I plug in like pi over 2. So pi over 2, the value of sine there is 1. Times -2 is negative, so your derivative is negative, which means decreasing. And then we do get a switch there. The original goes increasing to decreasing, so that's a relative max at 0 because that's the place it's switched. And then I plug back into what to find that y value? The original. So what's cosine of 0? 1. And then 1 times 2 is 2. So what is the relative max? This is like just the wording of it. What is the relative max? 2. Where does it happen? Just making sure you know how to answer those 2 questions. Opposite, okay. Other one, that was probably the hardest one I thought. But other ones on the, yeah. same result, right? But that's a good point. Other questions on 5-4? So I said just do like part A and oh no. Okay. They're giving you a derivative here, and they're asking where f. So they're giving you f prime. And they're asking where f has a relative max or relative min. So if I gave you f and said find the relative max or relative min, what's the first thing you would do? Take the derivative. And then what would you do with the derivative? Set the top bound equal to 0. Well, they just already did the derivative part for you. So you're just going to set that equal to 0. So I'm going to go x squared minus x minus 12 times g of x equals 0. Well, I can factor that. So that's x minus 4, x plus 3, and then g of x. So that's just like my three pieces. So if I solve this, what do I get? X equals 4. If I solve that, I get negative 3. And if I solve that, what do I get? Read through the sentence at the top. So what I'm asking you is, when does g of x equal 0? If g of x is always negative, when does g of x equal 0? Never. So this just like doesn't matter. And then, so I've got something at positive 4 and negative 3. So that's garbage. So it's one of those two, so it's like, is it a relative max or relative min? So I'm going to go negative infinity to negative 3, negative 3 to 4, 4 to infinity. Pick a representative point. Let's say I pick like negative 5. So I got to plug negative 5 into this. Plug negative 5 in there, positive or negative? Negative. Negative. What's g of x always in this problem? Negative. So negative times negative times negative is negative. So the original is decreasing there. And I would stop. I know it's not the positive 3 and negative 4 because I have positive 4 and negative 3. And then if I'm decreasing here, that means my original is going down. It can't be a max, right? If the first part's decreasing, it can't be a max, so it has to be a min. If you wanted to feel more comfortable, plug in 0. Like pick one in this interval. Be negative times a positive times a negative, which would be a positive, so we are increasing, and that verifies that that's your relative. Let's go to 5-6. So, chapter 5 is like, it's gonna have like two tests. There's the quiz, the take-home quiz, where I'm just trying to get you to be able to graph everything. And then we're gonna go back and sweep through things and do like the graphing, like where they give you a graph and you have to analyze it. So we are kind of skipping some things the first time through, but we will definitely go back and pick them up. Concave. Alright, so concave up. We talked about this slightly, I think. Concave up looks like that, or if you separate it, it's one of those two parts. And then concave. So I think about that like concave up, the U, it looks like a U. What, if you had to describe what is happening to the slope of this as you go? That's what I want you to think about. So let's say, like, what's the slope right there? I don't need a number, but would you agree that's a negative slope? If I said, what's the slope right here? Again, I don't need a number. Well, that's probably 0, right? So I got a negative number and then 0. And then here would be a positive number, right? So what is happening to the slope as you go? It's increasing. So my slope is very negative, and then like a little less negative, and then 0. So if your bank account went from very negative to a little less negative, and then 0, that's increasing. positive and then more positive. So concave up is when f prime of x is increasing. The concave down is the opposite. So I think about the n, because the n kind of looks like that. So it might be the whole thing or it might be just part of it. But either way, I can do the same thing. If I look at the slope like right here, that's very positive, right? And then it'd be like a little less positive, and that would be 0, and that would be negative, and that would be really negative. So what's happening to our slope there is it's getting small, it's decreasing as we go, right? So that's the definitions of concave up and concave down. So if f is concave up, then f prime is increasing. If f is concave down, then f double prime, f prime is decreasing. So then if I think through this next step, increasing means derivative. Because if something's getting bigger, then it has a positive slope, right? So if it's increasing, I know the slope is positive. That's like a derivative. I'm talking about the slope if I say increasing. If I say f prime is positive, that just means above the axis. If I say it's increasing, well, now you're going to look at the slope. So I'm taking this, I look at f prime, and I take the slope. But isn't taking the slope the same as taking the derivative? So if I take the derivative of the derivative, I'm at the second derivative. So if the second derivative is positive, that means f is concave up. Second derivative is negative, that means f is concave down. So if I looked at that graph, just to like talk through what concavity looks like, the sine graph is nice because it's like pretty crystal clear where it changes. Well, hopefully it is. But the idea is we got like a U here, and then like an N there. You see that flips from like curving upwards, then all of a sudden it switches to curving down, and then it switches back to curving upwards, and then it switches back to curving down. So the points where it switches, so there, there, and there, are called points of inflection. Where? Okay, so if you kept going, because you know what's coming over there, right? This is one also, because it's going to come. I just didn't do it because it's not like clear that the graph keeps on. Okay. Find the intervals over concavity. So this is the same process you guys were doing for increasing and decreasing. You're just doing it at the second derivative level instead of the first derivative level. So the process is going to look super familiar. So let's write this kind of on the side somewhere. Is there like a paper, a blank space near your? Not very. 1, 4, 5.7. So after our section. That's perfect. I'm trying to summarize what comes from each level. So that's going to come in handy because, like, on your take-home test, I'm going to give you an equation, and you got to find all of these things, and then put them all together into a graph and show me what the graph looks like. question says find the intervals of concavity. So as soon as it says concavity, I don't really care about the original. I need it to get to the second derivative, but I'm not going to plug into the original. I'm not going to worry about the derivative. Concavity comes from the second derivative level, so I'm just going to find the second derivative first. So the first derivative would be 4 times 1/4 cancels, and you get an x to the third minus 12x plus 1. Oh yeah, you got to put back. And if I asked you for increasing, decreasing, relative max, relative min, you would stay at this level. Set it equal to 0, get your intervals, plug in, and do all the stuff you did yesterday. But I'm not asking you for that. I'm asking you for a concavity. So before we do all that stuff we did yesterday, we have to get to the second derivative level. So it'd be 3x squared minus 12. And then the same exact thing that you did in the first derivative. You set that equal to 0, and you set the bottom equal to 0. If there is a bottom, you're finding like second derivative critical points. So if I set this equal to 0, it would be 3x squared equals 12, or x squared equals 4, or x equals plus or minus 2. So those are my two critical points, and then I build my intervals around those two critical points. Same exact thing we did yesterday. Can I erase this? You can go ahead and set it up and try it. Like, you know what's due. Same as yesterday. You go negative infinity, negative 2, negative 2 to 2, 2 to infinity. You're going to plug into, if we're looking for concavity, what level do we plug into? Second derivative. So, critical points were negative 2 and 2. I used to do it with commas. I like his chart way better, but the commas are still in my brain. So x, f prime, will have double prime of x. So I don't really care about f prime in this situation. I want to know if f double prime is positive or negative. Because that will tell me if f is concave up or concave down. So I'm going to pick a representative point. Let's say it was 3x squared minus 12, right? Let's say I pick like negative 5. If I plug negative 5 in there, I get like 75 minus 12, so that's positive. So your second derivative positive means your original graph is concave up. Same thing with the next interval, so negative 2 to 2, I would pick 0, because that's the easiest. Plug 0 in there, you get a negative second derivative, which means your original is concave down. So we switched, right? So that's going to be a point of inflection, because at negative 2, it switched from going down to going up. And then if I plug in like 10 for this window, it'd be like 300 minus 12, which is a positive number. So concave up. So let's switch it again. So with a relative max, like in the first derivative level, this is easier than the first derivative. First derivative level, we care whether the derivative switched from positive to negative or negative to positive. Because it changes whether it's a relative max or a relative min. This doesn't matter. It's a point of inflection regardless of which way it's switched. So you don't have to worry about like, is it a point of inflection max or min or something. It's just a point of inflection no matter which way it's switched. So point of inflection at negative 2, comma, where do I plug in to find y values? The original, which I don't even, oh, it's right there. Oh my god. Okay, something, and 2 comma something. I don't care about the something right now. I care that you can see that because we switched from up to down, down to up, at those 2 spots, those are points of inflection. I'm not worried about plugging negative 2 into that mess. It's not that bad, but questions on the rest of it? Yeah. Didn't we find that? Yeah. No, you're right. The directions are. I'm going like I'm trying to do what's going to happen on your quiz. So no, you're right though. Intervals of concave down, here we're concave up. So you just like organize the chart, I guess. Okay. Look at the note box there. A point of inflection is where the graph changes concavity. And I see this like two common mistakes. I almost don't want to tell you. I'm just like putting them in your head then. Does that make sense? Or should I tell you? What if you wouldn't have made them? Because I said it, and now you're gonna make it. I'm just like, I'll show you, but I worry that I'm showing. So the two mistakes. Just because f double prime equals 0 doesn't mean it's a point of inflection. So you can get a situation where like that'd be a relative max or relative min, but it's not going to be a point of inflection. So that could happen. I meant this, not this. Just wait a second. Assume that, and then just because f double prime is not equal to 0, that doesn't mean there's not a point of inflection, because there's two ways you can get the critical point from that level. One is if the second derivative equals 0, and the other is if the second derivative is undefined. So if you had 0 at the bottom. So I don't even know if this is helpful because you haven't done a problem yet, really, but don't just like, basically never assume. Always plug it in and check. What's the question? The concavity switches from, or f double prime switches from this positive to negative, or f double prime switches signs. Number 2. So that is a graph of f prime. So this graph is the derivative level. They're asking me about points of inflection and concavity. What level do points of inflection and concavity come from? Second derivative. So I'm looking at the first derivative, and I need to be able to think about the second derivative. So how do I take, I've got to take the derivative of this graph, basically. How do I take the derivative of a graph? You look at the slope of it. So this is decreasing up until there. So if f prime is decreasing, go back and look at the first page notes. F prime is decreasing. What does that mean is true about f? It's concave down. So we're concave down from some -4 with a parenthesis up until -2. I can't I'm sorry, that's negative. Yeah, is that -2 or -1? So I can't include -1 because I can't take the derivative at -1. Why not? That's a corner. So concave down here because the derivative is decreasing. That's just a definition you've got to know. If the derivative is decreasing, that's concave down. So we're also decreasing from 1 to 2. And if I had to justify that, they didn't really ask me to, but you will be asked to later. I would say because f prime is decreasing. So the slope of f prime is negative, which means the derivative of f prime is negative, which means the second derivative is negative. And then concave up would be the rest of it. So -1 to 1. And 2 to 3, and I can put a bracket at 3 because that's a closed point. If you had to justify it, you would say because f prime is increasing. Or if you wanted to, instead of decreasing, you could say might help because I think most of you guys kind of realize slope is derivative, but decreasing is derivative. I don't know if you quite have your mind wrapped around yet. But if slope is derivative, and I'm taking the slope of the derivative, that puts me at the second derivative. I just sometimes think about like if some random, maybe you guys feel this way too, but if some random person walked in, like what I said just makes like 0 sense.
That's what I just said the other day because you were just going deep ink, 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 and I was like, what if
Those
I,
aren't even words.
I was like, what if I just walked in not knowing this?
But even this, like, well, the derivative of the derivative is the second derivative. I don't know. It just sometimes I'm just struck by that. Points of inflection would occur at. So where do we switch? Where does the concavity switch? X equals -1. So this would not be points of inflection come when the second derivative is 0 or undefined. Which one will this be? Undefined, undefined, and that will be 0. So x equals 1 is your next one. You're right, Carter. That's undefined also, and then x equals 2. That one is slope 0. Questions on 2. Try 3. Well, you probably already have. I don't know. Try 3. I mean, that's really up to you. That's not true. It is pressure, it's not pressure. But the slope of that is 0. So you got decreasing, increasing, and then like nothing, and then increasing, and then nothing. So you'd say, that goes down to -2. Did you realize that the second number 3 is the second derivative? Okay. So yeah, I didn't realize that when I was just hoping you did. Yeah. So when the second derivative is positive, what's true about the original equation? Can't give up. First derivative positive means increasing. Second derivative positive means can't give up. So where's the second derivative positive here? Negative infinity to -3. And 1 to 3 is concave up because the second derivative is greater than 0. So we're above the axis. And then concave down, -1 to 1, no, -3 to 1, and 3 to infinity. Concave up because the second derivative is greater than 0, because it's positive, because we're no, that's the same thing. Yeah. We're concave down here because we're below the axis. Oh my god. This stuff takes a while to kind of wrap your head around. It won't be on your take-home test. So we kind of like hit it here with the stuff I'm preparing you for the take-home test, and then we come back and hit it like a lot more before your unit test. So I'm just kind of introducing just have to turn your head sideways. It was correct. Oh my God. Number 4 is kind of a. Do you remember this from a couple of units ago? I had this graphed in Desmos. So the way you do number 4 would be like graph it and then figure out. Desmos graph. What is it? X e to the negative x? X times e to the negative x. So they're asking you, would a tangent line at x equals 1, right there, be an overestimate or an underestimate at y? Don't shout it out, don't shout it out, don't shout it out. This goes back to, this was on your last test. You hadn't really learned what concavity was yet, but we learned if a tangent line would go above or below the curve. So if you remember, and you don't necessarily have to remember it. I don't have it memorized in my head. Like, oh, concave down means over whatever. I don't know if that's right. Like, I just look at it. If I draw a tangent line here, if I draw, a line that would just hit that at one point, is it going to go over or under? It's going to go over. Now the reason is calculus. Why is that going to go over? Okay, so like this tangent line is only touching in one place, but that goes under. What's the difference between those two things? Yeah, it's the concave. So for number 4, it's an overestimate. And the justification is because F is concave down. So while your line stays straight, you're curving down and down, which makes your line an overestimate. Okay. Questions I can answer right now? All right, let me take a look at your. I don't think we're doing the next section. Tomorrow's Thursday, so you don't have school. I'm going to give you some more problems tomorrow and time to finish this up. So I would probably try to get like half of it done, like maybe the odds. And then I'll take questions on those. I'm gonna give you a little bit more practice with it, and we'll finish. We're not doing any lessons. Looks like a work day, but I am going to provide a little bit more work also. In addition.
Are you gonna post that on
The thing that I,
Yeah.
oh yeah, you're gonna be here, right? Yeah.
Okay.
I'll probably grab like some AP practice questions. We'll look at that.
Can you also post the answers online to that?
Yeah.
I can like check it.
But then we'll keep going next week. Your take home quiz is probably gonna be like middle of next week. You're like almost there. End of next week. No, it won't take that long. That's a whole other week. I'll give it to like, let's say for example, I give it